Greetings and welcome. In today's video, we're taking another look at probability and odds and looking at some more advanced problems that require combinatorics. So for our first example, 12 male and 16 female students have been selected as equal qualifiers for 6 college scholarships. If the awarded recipients are to be chosen at random, what are the odds? All right, so that's important to point out. That 3 will be male and 3 will be female. So the first thing I'm going to actually do is let's figure out what the probability that we have 3 male and 3 female. Alright, and then I'll convert to odds later. I always find that more interesting anyway. So how many ways can I pick 3 males out of 12? Well, the order doesn't matter, so this is going to be a combo 12-3. And how many ways can I pick 3 female out of 16? Once again, order doesn't matter, so it's 16, 3 taking a combo. And then since those are both independent of one another, I can multiply them for the total number of ways that can occur. So this is the number of successful ways the event occurs, and I need to now put it over the total number of ways the event can occur. So how many students are being chosen from total? That would be 28. And there are 6 students being chosen from the 28. So this is going to be the number of ways you can just pick any 6 students from the 28. So let's actually evaluate this. I'll use my handy-dandy calculadora. So let's see, 12 combo 3 is 220. 16 combo 3 is 560, and 28 combo 6 is much larger. And let's see, 220 times 560 is 200 over 376. 740. And let's see, I believe that this can be reduced. So let's see. And it looks like it reduces to 880 over 2691. Now, this fraction is still worth being aware of because basically there's a little over 1.2 million ways that I can pick 3 male, 3 female, and then it looks like I've got a... Wait a minute. Yeah, 1.2, and then this is... Am I missing a number here? 376740. Seems too small, right? Did I do that wrong? Oh, that's what I'm saying. Not 1.2 million, 123,000 over 376,000. So this is an equivalent and reduced fraction over here. And I could also represent this as a percent or decimal if I wanted to. So that's the probability of it. And I just want to point out that S was the 123,200. T, or S plus F, was the 376,740. So if I'm going to figure out odds, I'm going to have to figure out what F is. And the way I would do that is by taking S here, plugging it in here, and subtracting it from both sides. So F is just going to be the 376,740 minus the 123,200. So the number of ways this event could fail, 253,540. And one of the things I want to point out is a problem like this. A lot of people would approach it and be like, well, probability would suggest that it should be 50-50 or something like that. However, in this case, it's more likely that it will be some other combination of male to female than it would be exactly 3 and 3. So I just want to point that out, that it's not always intuitive to be able to approach it. So the odds of 3 male, 3 female is going to equal the number of failures, or ways it can, oh sorry, the number of ways it can succeed, my bad, 1, 2, 3, 2, 0, 0, over the total number of ways it would fail. So it's a ratio, right? And then I could reduce that as well. 1, 2, 3, 2, 0, 0, divided by the second answer, math frac, and I get 880 over 1811. So here's the probability, here's the odds. Also, I want to point out that if I just subtracted 880 from this denominator, it would have given me this one here as well. And sometimes in a problem like this is where writing it as a decimal or percent can be somewhat more interesting, perhaps. So there's the setup for that problem. Notice I actually approach probability questions each time as trying to figure out as two separate combinatorics problems, one for the numerator, one for the denominator. Now, it actually would have been somewhat difficult to figure out the denominator situation and would require some probabilities that we'll look at later on in this chapter in order to do so. So that's why I found the probability of success over total and then converted to find the failures first. All right, let's look at this problem. Of 7 kittens in a litter, 4 have stripes. 3 kittens are picked at random. All right, once again, random is key. Find the odds. All right, so once again, I'm not interested in the probability for these. I'm interested in odds, but I might still find the probability first. So find the odds of each event. So I'm interested in what is the probability that of the 3 chosen, all 3 are striped. Right? So how many have stripes? There are 4. How many am I picking? 3. So that's the number of successful ways that event can occur. Over the total number of ways the event can occur, there's 7 kittens total. So combo 7, 3 would give me the probability. Now, this is why I want to point out that this is a little bit more complicated if I did want to put this over failures and find the odds right away. Because not 3 striped contains a variety of situations. I mean, it could have been 1 striped, 2 not, 2 striped, 1 not, or all 3 not striped. So I'd actually have to find all of those individual probabilities and add them up. So that's why I choose to do it this way first. So let's see, 4 combo 3. I think that might end up being just 4. Yep. And then 7 combo 3 is 35. So there's our probability. But now if I want to find the odds of this event, I'm going to basically switch this from total for the denominator to failure, and in order to figure that out, I can just subtract the successes from it. So 35 minus 4, I guess I could write it this way, is 31. So here's the odds of the event occurring, 4 to 31 odds, right? Problem 10 is only 1 has stripes. So probability, I sometimes like to write that as exact 1 stripe. And the reason I want to use the word exact is that later on we'll consider at least situations where at least 1 is striped, so then you'd have to find the probabilities of exactly 1, exactly 2, and exactly 3 all added together. So let's see, how many ways can I choose one of the striped cats? Well, of the 4, I'm picking 1. But now I have to consider I'm picking 2 other cats from the remaining 3, right? So combo of the 3 not striped cats, I'm picking 2. Multiply those because those are independent events. And that will give us the total number of ways I can get exactly 1 striped. Over the denominator is actually the same from the previous problem, right? Because it's still, I'm picking 3 cats of 7. So let's see, so combo 4, 1, I believe is actually going to be 4 again. Times combo 3, 2, I think is going to be 3. So I believe 12 35ths is my answer. 5 and 7 go into that, so that doesn't reduce. So there's the probability, and then if I want odds of the situation, I'll just ditto mark that. I'd do 35 minus 12 to find the failures, right? Total minus success would give me failure. So that is 23. 3. 12 over 23 is the odds of that situation. And then the last quick question is, 1 is not striped. So the probability of 1 not striped. And that is the same. I could word this as exactly 2 striped, right? Is the other way I could word that, right? 1 not striped is the same as exactly 2 striped. So how do I figure out that probability? Whichever way I'm viewing it. So of the 2, there are 4 striped kittens, and I'm picking 2. And there are 3 not striped kittens, and I'm picking 1. So there would be my numerator over my same denominator in this case, because I'm still picking 3 kittens. So combo 4-2, that one I might reach for. 6 times combo 3-1 is 3 over 35. So 18 over 35 is the probability of that event occurring. And if I want to then figure out the odds of the same event, I would subtract 18 from the numerator, or from the denominator, in order to figure out the number of failures, doing total minus successes. So 35 minus 18, what's that going to be? Is that 17, I believe? Yes. So that means it's most likely so far of all of these odds that I'll have exactly 2 striped. Actually, let me take a look. Exactly 2 striped, exactly 1 striped, 3 striped. I've actually figured out one of the interesting things. I might add one problem. Check out this probability, this probability. So 3 striped, 1 striped, 2 striped. If I add up all of these, I'm missing one case. So 4 plus 12 is 16. 16 plus 18 is 34. Right? Yep. And so 34 out of 35 cases are counted here. What's the remaining case that I'm missing? Let's see. I've got 3 striped, right? I've got 2 striped. I've got 1 striped. The other situation that I would have had to consider is, I guess, is a bonus question. What is the probability of no striped kittens, right? And that would be, now theoretically, it should be 1 out of 35, because I've already got 34 other cases counted here. So the probability of no striped, well, that would be of the 4 striped, I'm getting 0 of them. Of the 3 not striped, I'm getting all 3 of them over the combo 7-3. Combo 4-0 is 1. Combo 3-3 is 1, sorry, as well. And combo 7-3 is 35. So I actually end up getting the 1/35th. And I just want to point out, we've talked about probability of 1 being an event that is certain to happen. And if I add up all of these probabilities, since these are all 4 of the possible situations, I would get 35 over 35, which is 1. And it's absolutely certain that we will have 1 of these situations, right? You'll either get 3 striped, 2 striped, 1 striped, or no striped kittens, right? And that's what I want to point out, is just that we would have expected that all of these added up to 0. Let's see, one more quick example. I kind of find this one interesting. Interesting testing habits that Miss Robinson has here. It says, Miss Robinson gives her pre-calculus class 20 study problems, and she will select 10 to answer on an upcoming test. Carl can solve 15 of the problems. So find the probability that Carl can solve all 10 problems on the test. So probability, Carl solve 10 problems, right? So how many ways, and this is assuming he wouldn't know how to do the other 5, right? So, or actually, no, sorry, it says he can't solve, so that would imply he cannot solve the other 5, right? So let's see, so probability Carl can solve 10. How many ways can he solve 10 out of the ones he knows. Well, let's see. He knows how to solve 15. So as long as we choose 10 from the 15 he knows, that would be the number of successful ways this event could occur. Over, how many ways can I just choose 10 problems in general? Well, there's 20 problems to choose from, and I would, have 10 to pick, right? So here's part A, I suppose I should signify. So 15 combo 10 is 3003. And 20 combo 10 is a 184756. If I divide those, I get a decimal 0.01625. So I've got like a little over 1.5% chance that Carl's going to be able to get all 10 right based off of his chances. And if I convert to a fraction, this is the same as 21 over 1292. So that's the number of ways, or the probability that Carl can get all 10 right. Let's look at part B. First of all, part B, I notice, is looking for odds, so I don't want to misanswer the question by giving probability. However, I'm going to start with probability because often that will be very helpful for us. Carl, solve 8 problems. All right. So the number of ways this can occur, well, the successful way it can occur is that of the 15 he knows how to do, he gets 8 of those, right? But I have to consider another case as well. What about the other 2 problems? I need to find out how many ways can those other 2 problems come from the ones he doesn't know how to do. How many problems does Carl not know how to do? 5 of them, and we're picking the remaining 2, right, from those 5. And then the denominator here will be the same. So what would this look like? So 15 combo 8 is 6435, but I do have to consider that there's other ways that I could get those remaining 2. So 5 combo 2 is 10 over, and as I said, this denominator is the same. So it looks like this would be 64350, just tacking on the 0 at the end, over 184756. And let's see what this reduces to. Because both of those numbers are even, I know for certain they can reduce. 184756. As a decimal, I'm getting 34.8% chance that he will get exactly 8 of them right. And then when I reduce this, it's a 225 out of 646 chance of that occurring. Now this is the probability of that event occurring. What if I want to know the odds of the same event? There's my sad looking ditto marks. Well, the way I could do that is take the successes and put it over the total minus the successes, right? Because that would give me the failure, and that's what odds is, the ratio of success to failure. So 646 minus 225 is 421. And does that reduce? I don't believe so. No. So that is the odds of him getting exactly 8 right. Now, I could ask interesting questions of, for instance, what is the probability Carl gets at least 8 right? And then what I'd have to do there is add the Carl getting 8 right, Carl getting 9 right, and Carl getting 10 right, add all of those probabilities together to answer that question. But we'll talk about some problems like that in future videos. So anyways, thank you so much for watching, and have a great day.